All right, double check 4.1. A couple of things. I'm going to go through this pretty quick, so please make sure that you obviously pause, rewind, and do whatever. So now remember, by definition of an inverse, what this is saying is that f of g of x, the composition of f of g of x is going to equal x, and that g of f of x is also x. So because of that, so you're going to have to plug one into the other, and it has to work both ways. So if you show that it doesn't work, then you can stop. If you show that it does work in one direction, you do have to do it in the other. So we're going to start with f of g of x. And so when you do that, I'm going to take g, I'm going to plug it in for x. So apparently I need to get the board calibrated, sorry. And so you're going to go ahead and do that, and there's supposed to be a 4. So you're going to multiply that out. So then you've got, oh, and then minus 7, sorry. So then you're going to get 4x over 4 plus 28 minus 7, so that's going to equal x plus 21. So not an inverse. Ta-da! Now for the next one, same idea. Now this one, everybody's going to cry quietly to themselves. And remember, you've done stuff like this before. So first of all, okay, it's just rational functions. I'm going to take this, I'm going to plug it in for x. So I've got 3 over x minus 1 plus 3 over 3 times x minus 1. Now you've got two options here. You need to find a common denominator, and the top would be one of them. You know, I'm going to do one in one direction and one in the other, so option 1. So what you're going to do is you're going to say, okay, my common denominator here in the numerator, or in the numerator is x minus 1. So I need to multiply this by x minus 1 over x minus 1. And what that's going to get me is it's going to get me a single fraction in the numerator. So now I have 3 plus 3x minus 3, and then all over 3 over x minus 1. So that's going to become 3x over x minus 1 over 3 over x minus 1. And then once you have the two fractions, then you can remember that's essentially division. So I'm going to take 3x over x minus 1 times x minus 1 over 3. And then at this point, things divide out. The x minus 1s are going to divide out because they're single factors. The 3s are going to divide out, so I have it equal to x. So that's one way. And I'm going to show you the other way you can do it. Now, you can use the same technique on the other one. I'm going to go ahead and do the second technique just so you can see what that looks like, because it generally will save time. However, it's somewhat trickier to see. Actually, it's pretty easy to see on this because because the denominator is going to be the same as we go through this. So at this point for this one, I'm going to take this function and plug it in down here for x. So now I've got 3 over x plus 3 over x minus 1. Actually, this would have been a better one for that one. So I'm going to multiply this by x over x. 3 stays on the top. On the bottom, I get x plus 3 minus x all over x. So now I've got 3 over 3x. So again, then that's going to turn into 3 times x over 3 because I'm multiplying by the reciprocal. And that will just equal x as well. So yes, it is an inverse. And I need to see all of that for this to work, not just changing one into the other or choosing it. You know, I want to see it through the definition of an inverse. For finding inverses, this one right here, first of all, I missed the brackets. So my deepest apologies. Go ahead and put that back in there. So this one, domain and range. Domain is just going to be all your x values. Range will be your y values. If you remember from when we were talking about how to find inverses, you have to swap your x and y values. So the actual inverse here is going to be, you're going to pull 5. You're just going to swap the x and y categories, etc., etc., etc. Ooh, this actually isn't well, the inverse isn't a function. Just notice that. This is why you proofread. Because of this right here. So it's not 1 to 1, but we digress. All right, so first of all, you got to swap x and y. So you're going to get x is equal to 3y plus 8. And that is your inverse. Pretty simple, pretty easy. Again, remember what you're doing is you're going through and you're undoing everything to solve for the y. And you've solved for y before, you've done literal equations, so just a little bit more involved. Same thing here. So now I have x is equal to the square root of 2y minus 7. So you're going to square both sides. Add 7 to both sides. And then divide it through by 2. Now, here, and this is kind of what was going on after for the domain and range. Here, your domain has to be what? So you get 2x minus 7. That has to be bigger than or equal to 0. So that means that 2x has to be bigger than or equal to 3 halves or 7 halves. Okay. And your range is going to be 0 to infinity because that's the lowest number that you can plug in here. So for this one, your domain and range are going to be swapped. So, oops, that should be a 2. Somebody should have stopped me. So in this case, now the range of the original function is going to become your domain of the first one. So I can only plug in numbers for that. Now, technically, you could look at that and say, oh, I could plug in any number that I want. But again, remember, for it to be a function, or to be an inverse of a function, it has to be a function back as well. So, and again, the main goal here is can you find the actual inverse itself? The domain and range stuff will come next. All right, so for this one of the last ones, x is going to equal 2y minus 5 over y plus 3. First thing you want to do is get rid of the fraction. Because the bonus part of that is going to be then you don't have to worry about the fraction so much. So you're going to, since we have an equal sign here, you can go ahead and, well, to get rid of it, we're going to multiply both sides through by y plus 3. Or if you want to think of it as cross-multiplying, so be it. And then you just have to get everything with a y on one side so we can solve for it. So when you do that, the 2y is going to move over. I'm going to subtract the 2y from both sides, and I have to subtract the 3x from both sides, so I get this. And then you're going to factor out a y. Now again, domain and range things here generally, I mean, the only number that's not going to work is going to be x equals negative 3. So it's going to be the only number that's actually not going to work in your domain for the new one. So you get this. No, you may not cross off the x's. Don't even be tempted. We are way past that, boys and girls. You know, I should put like a secret word in here that you guys have to come and find out and get credit for or something to watch these things. And then you're done. Okay, and then I think we got one more. Nope, that's it. All right, well, that was simple and easy. If you have questions, call or text me. Come in at lunch. Otherwise, I will see, or before school, and I'll see you then.